All right. So you're being recorded. Just so you know how this deal works, like I'm recording the lesson right now. So whatever you see my hand doing and my voice speaking, if you pulled up the video on YouTube, you would be able to see it. Okay. So anyway, just so you know, and not very many of you have friended the Facebook page, and that's where I put the videos. So just so you know. You have to go to the Canyon Calculus Facebook page. It looks like maybe some of you have looked at the wrong one. There's a page that's attached to my own personal page that I created in the beginning. That's not it. You have to go. It's a totally different entity. Okay, and the profile picture is the cookie cake that they gave me last year. Just so you know what you're looking for in terms of the profile. Okay, so the day you've all been waiting for.
The shortcut?
Mm-hmm. And this is section 3.3. Okay.
Oh, is actually like a lesson in the book.
What's that?
I didn't know it was like an actual lesson.
Oh yeah.
Shortcuts.
We're just gonna do it the long way all year.
I mean, that's what we've been doing. 3.1, like what I make your sections titled here in the notes correspond with your sections in the book. Okay, so if you're wanting to read more. Okay. So we're going to talk, well, it's not really a long way and a short way. It is how it's done, okay, which is what we've been doing because derivatives are really limits. And then sort of discovering this pattern and short rules for them. But yeah, I mean, they're imperative. You wouldn't want to do that forever. Okay, so these are derivatives that we have found. Okay, so if f of x is equal to 7, what is f prime of x? 0. Okay, because f of x equals 7 is a what? It's a horizontal line, right? And the horizontal, at every point on a horizontal line, you would have a derivative of 0, right? Okay, so we don't have to do work for that one anymore. Okay, so how about f of x equals negative 10x? Okay, f prime of x is negative 10. And that's because f of x is a line, and every point on a line has the same slope. And the slope, because this is in slope-intercept form, is negative 10. Okay, so here's one we've done a lot. X squared. Okay, and f prime of x ends up being, if you went through all of that, it would be 2x. Okay, so stay with me if you don't know the short rules. Okay, just stay with me and, we're going to see a pattern here. We found the derivative of this function as well. It's also parabolic, right? And we found the derivative here to be 2x plus 1. We found this one in last night's homework. And it was quite lengthy. And we found it to be that. Okay, what's happening between the function and the derivative? What's happening to the degree?
It's going down 1.
It's going down by 1, right? So something linear became a constant, right? Something quadratic became linear. Cubic became quadratic, right? Okay, and we looked at those graphs too. You had some graphs on your quiz, right? Okay, so what exactly is happening?
The degree's going down one, and then you multiply the degree by like the coefficient.
Okay, so here's what you guys are telling me. Multiply the variable by the degree, and then do what with the degree? Subtract 1. Okay, that's exactly what you do. Okay, and that is your first short rule for derivative. It's called the power rule. Okay, so another one that we did last night. Actually, let's do the bike ride. What was that? 40 thirds x squared. So what's the derivative there? 80 thirds x. Okay, is everybody following what we're doing? How we're getting the derivative? Yeah? Okay. Let's, yeah, only slightly. Okay. Let's see. We did that one last night, right? It was ugly. It was long. Okay, so Vinny is saying that this is the same as x to the 1/2 power, right? So this rewrite step here is very important for getting your derivative. Because I need to, if I can have this written in terms of a power, now I can apply that power rule. What did you guys tell me to do with the power?
Multiply by the coefficient.
Bring it down in front, right, and multiply it by whatever's there. And then what am I supposed to do with the power? Subtract 1. So if I take 1/2 and I subtract 1, I get negative 1/2. So when you look this up in the back of the book, there's its answer. What was that other kind of ugly one we did? There was...
So 418.
That's okay. Time we got it here at 2:05, right? Okay, so I don't have time to go through and summarize the rules, which we will do because we do have to get those down, and we have some other things. Well, we have lots of other derivative rules to learn with this. This is only one called the power rule, but you can do a little bit. Okay, so here's what's going to happen. I'm going to give you. Well, I want you were supposed to complete 1 through 8 in your worksheet last night, right? So on that worksheet, we want to do 9 through 11. Okay, so our homework is worksheet 3.1, 3.2, 9 through 11, because you've already done 1 through 8, right?
Yeah.
Okay. And then the other part is this derivative packet that I'm about to hand you. And we're going to do 3 through 17 odd. And they'll go super fast. It's actually this derivative packet that you're getting. Your textbook doesn't have a whole lot of practice in it, so I have to plagiarize and pull practice from other places.
You're a rebel of silly math.
No, I'm total rebel. Right. Okay, so I do want you, just so you're aware, I have also plagiarized the answers to the problems. If you look at the back of the packet, you do have the answers to the odds, okay? So you can see that this is, in this particular textbook, it's called section 2.2. So if you go to the back of the packet, you will see it says, section 2.2. Okay, and it has the answers there. Okay, so we're doing 3 through 17 odd, and 9, 10, and 11 in that other packet. Okay? Interpreting the derivative. So have those done tomorrow.
Give us an extra.
Thank you.
I mean, I tried to help them, but they're like,